So before I start, just I make quick review about the first part. So the first part we discussed about some important points. Number one, it's capacitors. What is the capacitor? Number two, capacitance. capacitor مكثف. capacitant سعة المكثف. And we know the definition of the capacitor. What is the definition of the capacitor? It's a small device that used in electric circuit to store the energy. So what is the capacitor consist of? It consists of two conductor plates or sheets, source as a battery, distance between these two and wires to connect, so it's very simple, easy. And we know if the source is with high potential differences, that delta V equal to Q. So if the dV high, so Q is high, the charge. If it's low, so that means the charge it will be low, so there is a proportional direct between Q and delta V. When I remove the function with equal, so Q is equal to delta C delta V. So here is the constant is C is a capacitance. So that is the first equation that we learned last lecture in part 1. And from the definition of the capacitors depend on, number one, epsilon, the permittivity I write it clearly, the permittivity سماحية, and it's equal to permittivity of the space of the the air is equal to 8.854 multiplied to 10 to power minus 12 coulomb square per Newton meter square. That is number one. So if I change the epsilon, so the capacitor it will be changed. Number two, the distance between the plates, so the distance. Number three, the area of the plates or the sheets, and we know from the definition C is equal to epsilon naught A D. So the proportional between the capacitance and the epsilon naught and area is proportional direct, and the capacitance with the distance it is inverse. So if these two increase, so that is increase. If this increase, that is decrease. And also we learn from the last part about the connection. So the connection of the capacitors and the sample of the capacitors, it's look like the sample of the battery, but it's equal to each other. It's equal. So you can connect the capacitors in series or in parallel. For series, it gives the capacitance smallest. Here the parallel, it gives the capacitance to increase. That is because the area it will be increased, and the proportional between the capacitors and the area, it is proportional direct. So if you increasing the area, that means you increasing the capacitance. And in series, the C equivalent, it's equal to 1 over C1 plus 1 over C2 till the M. For the parallel, the C equivalent is equal to the adding of the capacitors. So that we learn it from the last lecture. Today we start our lecture. It's about the chapter 3, capacitors. So first, prove that sigma, prove that E is equal to sigma divided by epsilon. المطلوب هو إثبات أنه المجال الكهربائي اللي ما بين اللوحين يساوي السيجما اللي هي الكثافة المساحية على السماحية. So we have two ways. First way, by use the definition. The two definitions is important to know. Number one, the first definition, that is C is equal to epsilon naught A over D. Second, from the relation between Q and delta V, C is equal to Q over delta V. So I have this, that is number one, or that is number two. Number three is delta V. Delta V is equal to E, the electric field, multiply the distance. So just substitute this in the equation of Q. Q is equal to C multiply delta V. So that is C. Delta V, that is delta V. So just substitute Q is equal to C, that is C. Delta V, that is delta V. Then D move with D. So E so Q is equal to epsilon naught A epsilon naught A E. Then from this equation, E is equal to Q epsilon naught. So I prove it by using the definition. By another way, by using integral. By using the integral, I know E is uniform between the plates. So just differentiate and integral. So E is equal minus dV over dx. Then dV is equal to minus E dx. So delta V, because the integral moves with differentiate, so delta V is equal to minus E dx. So cosine theta, so the theta between it, it's 180, cosine 180 is minus 1. So minus with minus, it's plus. The integration is definite from A to B. So from A to B, minus with minus is plus dx. So E is equal x to B. So it is the same way that you can find it. It's sigma divided by epsilon. So x means the area. So the area sigma, it's equal to Q over A. That is the second proof. So now Next part, it's about the cylindrical. So if you have a cylindrical capacitor, how you can find the capacitance? So you can use simple easy way. So first you can derivative, then integral. So that is the cylindrical. It has two. One is inner circuit, one is outer circuit. So inner circuit is RP, outer circuit is RA, as mentioned here. Sorry, I do big problem, so no problem. So that is in, that is out. That is out, RP, and the other one is R. This is the inside, so that is RA, that is RP. That is the L, the length. So I make the derivative for the area, for the length, sorry. So the length lambda is equal to Q over L. So the L here is 2 pi R, the semi-conference. So E is equal to lambda epsilon naught 2 pi R. Then integral. So VBA R capital to R small. E, so minus outside the integral, DL. So the integral of RA RP, it's equal to Q lambda, just I substitute with lambda, Q over 2 pi epsilon L. Then last part, VBA, it's equal to Q 2 pi epsilon L. That is the constant outside. So just I have here dr over r, so means 1 over r. 1 over r is equal to ln. So from my general equation, C is equal to Q over V. So Q, it's here. V, this part, Q divided by 2 pi epsilon naught L ln. رياضيا مقام المقام يصبح بسط Q moves with Q. So this move to here, 2 pi epsilon naught L ln RA over RP. So from the equation, what is C depend on? Think about it. So 2 is constant, pi is constant, epsilon is constant. So it depends on L and R, RA. Second part, it's about the capacitors with dielectric. So the capacitors have a dielectric, and the dielectric, it feels between the two plates to make it not touch each other. So what is the importance of the dielectric? The dielectric importance of it to break down, allowing the electric charge to flow less readily than the air. So it makes breakdown to the electric charge. To allow the plate to be placed closer together without touching each other. Experimentally, if the dielectric fields in the space between the two conductors, it is increasing the capacitance by a factor K. So there is a factor K. This factor K, it depends on the dielectric. So what is the K? The K is the new dielectric divided by the epsilon of the air of this, of the air permittivity. So see the capacitance of the new capacitors when you change the dielectric, that is for the new capacitance. So C without note here. Note means for the air. Here note means for the air. If it's used the constant value of epsilon note 8.85 multiply to 10 to power minus 12. If you use this value, so it is C note. If you use a new value, I saw it in next slides, the constant of the dielectrics. So from the definition, C for the new dielectric, it's equal to K epsilon naught A divided by D. So I know K it's equal to epsilon divided by epsilon naught. Epsilon for the new capacitors. Epsilon naught for the air capacitance if there is no feeling with any dielectric. So the epsilon moves with the epsilon. So for the new one, C is equal to the epsilon for the new mica, glass. So it gives for you the area of the new capacitors and the distance for the new capacitance. That is the table of the electric constant. So for the air, for the space, where is the space? 8 point. For the space that we used, it's 8.54, but it's common, so they not mention about it. Bicult 4.9, nylon 3.4. The dielectric strength, so that means if the volt per meter is more than, so that gives or that make the capacitors broken or crashing the dielectric if the voltage is more this value. هذه القيمة اللي موجودة هنا هي القيمة التي يتحملها العازل، فإذا زادت هذه القيمة فهناك يحدث عملية عطل في في الكاباسيتورز، وبالتالي يصبح تالف غير قادر على العمل. So the effect of the electric هذه مهمة جدا، ومن أهم الأجزاء في هذه المحاضرة هي هذا الجزء the effect of the electric. فهناك effect، هناك تأثير للدي إلكتريك. فهناك طريقتين للدي إلكتريك. when you change it with connecting، عندما يتم التغيير بوجود توصيل للدائرة الكهربائية، وعندما يتم التغيير مع فصل الدائرة الكهربائية. طيب الطريقة الأولى when I kept the battery voltage connected، ايش اللي يحدث؟ اللي يحدث هذا انا اعرف بانه الفولت كونستنت، بانه المصدر ما زال شغال، اذا V is constant and the charge it will be changed. اذا ال V هو مقدار ثابت ويساوي قيمة المصدر إذا كان 20 أو 50 أو 120 فولت، فهو نفسه لأنه ما زال المصدر يغذي الدائرة. So V is equal to K V naught ثابت، بينما المتغير هنا راح تكون هي ال Q. كيف أحسب ال Q؟ So ال Q الجديدة هي عبارة عن K Q naught طيب الكي ماذا تساوي؟ هي عبارة عن الإبسلون الجديد على الإبسلون للهواء. فبالتالي الكيو هي عبارة عن هذه الحسبة اللي راح تعطى من هذا الجدول. فمثلا للنايلون راح أعطيك هذا الرقم 3.4، تقسمها على الهواء كم قيمته، ثم بعد ذلك تحسب كم قيمة هذه القيمة وتضربها في الكيو الموجودة. كيف تحسب كيو؟ كيو عبارة عن السي في في نوت. فهو راح يعطيك سي وراح يعطيك سي نوت من، او تحسب سي نوت فتضربها في، فالكيو هي عبارة عن سي نوت في في نوت، وراح تتضح في المسألة. إذا أعطيناك مسألة راح تكون واضحة جدا. ف don't worry about this kind of question. It is very easy and all things it will be mentioned and clear. Just only know about the two important things in this way of connection. When still connection, so that means number one, V constant. Number two, number two, number two, number two,